Okay, we're supposed to draw the region. So x equals 2, the vertical line. Y equals 4, so horizontal line. Y equals 1 over x. Here it should cross at 1, comma 1. There should be a dot. Let's see, as x gets bigger, y should get smaller, so it should look something like this. Okay, so the region contained by those curves, it's bound here. All three of those curves create this region. You wouldn't want to shade this one because that's not a region. I mean, that's not a region bounded by all three curves. It has an infinite, there's no sides to it. Okay, so that's the region. Use the disk method to find the volume. The region is rotated around the x-axis. So we're rotating this way so that the region is coming across over here. And you're rotating from here to here to make a three-dimensional shape. So what I like to do is I like to picture the entire right cylinder from here to here. It's a really bad drawing. If you've seen my videos, you know I'm a bad drawer. But we got this big right cylinder, which is, let's see, this goes up to y equals 4. So that's 4 for radius. It's pi r squared times h, the height. So the distance is from here to here. We actually don't know the height yet because we need to find out when 1 over x intersects with y equals 4. And if you solve that equation, it intersects at x equals 1/4. So let's see, the height of this right cylinder, not the region that's being revolved, but the entire right cylinder that I just drew, starts on x equals 1/4 and it ends at x equals 2. So we got to subtract those to find out what the distance is. So it's 8 over 4 subtracted by 1 over 4, so that's 7 over 4. Okay, that's the right cylinder for the whole region. And then we can subtract out this dotted region that I'm making, and that will leave us with that shaded region. So we need to make an equation for that dotted region. So any right cylinder we draw in that dotted region, we're thinking about it being infinitesimally small. Infinitesimally, and I should say, height is approaching 0. So the radius constantly changes depending on where you are in this curve, y equals 1 over x. So that y distance is computed by calculating 1 over x. So for that red region that I'm drawing, we've got an infinite amount of them. We want to subtract that big region. We're going to integrate from x equals 1/4 to 2, because it starts at that x equals 1/4 intersection, then goes to x equals 2. And then the radius is 1 over x squared. So it's pi r squared, and then h is infinitesimally small. Okay, now I think the only thing left is to make the calculation, and then we're done. So we cancel out one of the 4's here. It's 28 pi subtracted by, let's see, that's 1 over x squared. So that's, think of that as x to the -2nd. So the antiderivative is going to be a negative x to the -1st. That way the derivative, the -1 would come down and cancel out the negative sign, bring us back here. Look at a pi. Okay, so we got our antiderivative. We need to evaluate it with the limits of integration from 1/4 to 2. That's 28 pi. And then subtracting a negative, we're going to change this to positive and get rid of that. Then if you plug in 1/4 here, you're plugging in 1/4. This is 1 over x, right? So it's 1 over 1 over 4. So it makes it 4. So we've got 28 pi plus a half of pi minus 4 pi. So that's 24.5 pi, which is 49 pi over 2.